Welcome to this explainer. Today we're diving into something that literally affects every single one of us every single day, yet it remains almost completely invisible. We are looking at the rigorous, incredibly high-stakes admissions journey that a humble candidate seed has to survive just to reach a commercial farm in Pakistan. Far from being some dry bureaucratic review, this process acts like an invisible shield, protecting the entire nation from crop failure and economic loss. It is an absolutely fascinating gauntlet of science, field trials, and DNA testing.
So how does a new seed actually make it to the farm? It's a question we rarely ask ourselves when we're strolling down the grocery aisle. But the truth is, the hidden science and the incredibly strict quality control behind our food supply are just mind-blowing. A seed doesn't just get planted because someone thinks it's a neat idea. It has to truly earn its place in the soil.
Okay, let's dive into this. The final reward of this journey is a beautiful, mature field of crops ready for harvest. A fully certified, officially approved commercial crop. But to actually get to this point, to ensure that this crop is safe, reliable, and high-yielding, well, that seed had to survive an intense, multi-year evaluation. Let's trace the path it took to get here.
Here's our roadmap for the journey. We'll quickly cover why we register varieties and who can apply, then decode the Form A application, the VCU and DUS exams, and wrap up with the rigorous testing and digital tracking. Let's get to it.
Section 1. Why register crop varieties? It basically comes down to creating a vital genetic passport for new crops.
The whole system is designed with some really crucial goals in mind. Sure, it preps crop inventories and creates necessary passports for the export and import of seed materials. But what's absolutely vital here is that it provides a basis for administering plant breeders' rights. This means the system isn't just tracking seeds, it is actively protecting the hard work and the intellectual property of the breeders who spend years inventing these agricultural marvels.
Section 2. Eligible applicants. Who actually gets to submit these seeds to the ultimate admissions board?
What I find genuinely amazing about this process is how inclusive it really is. The door is wide open to a huge range of innovators. We're talking massive public sector research institutes and private seed companies, obviously, but also autonomous institutes, universities, individual breeders, and yes, even everyday farmers. If you've developed something groundbreaking, the system is absolutely ready to test it.
Section 3. The Form A application. Think of this as the grueling university-style application for our candidate seed.
Just getting an application accepted is a massive undertaking. The applicant has to hand over a physical seed sample alongside a highly detailed morphological description. They have to provide early cultivation data and, get this, a complete DNA profile or genetic fingerprint. Oh, and there are special rules too. If the seed is a GMO, it requires a strict environmental clearance certificate from the Ministry of Climate Change, proving it has zero adverse effects on the environment or human health.
Section 4. Decoding VCU and DUS. If Form A was the application, these are the grueling final exams.
Let's start with VCU, which stands for Value for Cultivation and Use. So the crucial point is this: agronomic value is the single most important criterion for commercial varieties. To pass VCU, the seed can't just be some new invention. It has to prove actual superiority over existing commercial varieties in at least one key area, like yield size or crop quality. If it isn't measurably better, it just doesn't get approved. No exceptions.
Next up is the DUS criteria. DUS stands for Distinctness, Uniformity, and Stability. And this is the ultimate test of the seed's true, reliable identity over time.
Let's break down that first letter. Distinctness. Think about the stark, completely obvious difference between a cotton plant and a sunflower. A new candidate seed has to be clearly distinguishable from all other existing commercial varieties by very specific characteristics. As the rules state, if a new variety isn't genuinely different from what's already out there, there's absolutely no point in releasing it. It literally has to stand out from the crowd.
Section 5. Rigorous seed testing procedures. Time to leave the paperwork behind and get our hands dirty in real-world trials.
Out in the actual field trials, the crop is tested for those other two letters in DUS, uniformity and stability. The crop has to prove it grows uniformly. Furthermore, it must be stable, meaning it stays true to its distinguishing traits harvest after harvest. And this isn't some quick check. These trials normally span 2 whole growing seasons, sometimes even a third. Variations aren't caught on paper. They are caught right here in the dirt.
Now, historically, evaluating genetic purity relied on visual comparisons out in the field. But let's be real, relying solely on observing plants can be incredibly time-consuming, expensive, and sometimes completely unreliable, especially for traits you literally can't see, like pest resistance. That is exactly why the scientific community has made this fascinating shift toward PCR-based testing. They use highly accurate DNA profiling and molecular assays now to definitively determine seed purity. It's a game changer.
Now, what's really interesting is the sheer scale of this gauntlet. The journey starts with the breeder, moves through micro and zonal trials, and then splits. The Federal Seed Certification and Registration Department handles DUS testing, while the Variety Evaluation Committee handles VCU. Only after surviving all of these intense evaluations does it move up to the seed councils, culminating in official notification by the federal government.
Section 6. Digital tracking and approval. Managing all of this science definitely requires some serious infrastructure.
To keep the whole operation running smoothly, Pakistan's Federal Seed Certification and Registration Department uses a centralized online management information system. Applicants actually log into this MIS portal to initiate and track their seed's ongoing journey through the certification process.
Behind this secure login, mountains of data get submitted, and the standards to even participate in these final stages are unbelievably high. For example, before DUS testing is finalized, the maintainer has to supply seed for the trials, and the purity of that seed can in no case be less than 99%. Seriously, a 1% contamination could mean complete failure.
Finally, we reach the end of the line. Once a variety is approved, it's officially registered, and key information, like its development history and area of adaptability, is published for the world. But here's the catch. The journey never truly stops. If at any point in the future the seed loses its distinctness, uniformity, or stability, the registration can be outright canceled. It has to maintain its excellence literally forever. Which leaves us with this final thought. When you look at the grueling trials, the DNA fingerprinting, and those strict 99% purity thresholds, you really have to ask, how vital is genetic purity and rigorous testing to the very future of our global food supply? Every single commercial seed on your plate has a massive scientific history behind it. Thank you so much for joining me on this explainer, and next time you see a field of crops, remember the incredible journey those seeds took just to get there.